side. All right, so when we talk about parallel circuits, these are objects that are placed, in a circuit that are split by wires. And so what happens is, you have current that's coming in, and if it's equally split, let's say, you have three light bulbs that have the same amount of resistance, you'll have a third of the current going through the top, third through the middle, and a third through the bottom. And if you notice here, the current coming in, is being split up, but then, they all come back together here, and there'll be the original current again as it leaves the parallel section. The way that we add up resistors or light bulbs in series is 1 over Req. So 1 over Req is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So we add up our resistors and we get our total. So if a circuit connected to a 6-volt battery or cell, 3 is 3 light bulbs, including a 4, 8, and 11 ohm in parallel. And we want to draw the circuit and find the current flowing through the circuit. What I'm going to have you do, like I did for the other tutorial, is go ahead and go to FET. Go to, Google search FET, circuit, construction, kit, DC only. And if you Google search that, you can pull that up and then make a circuit that looks like this. You're going to have the cell at the bottom. You'll have an ammeter here. And then set up 3 bulbs in parallel. You have the 4, 8, and 11 ohm. And you'll be able to see what's happening with the current there. So what we want to first find out is what is the overall current in the entire circuit. And so we have our resistors set up in parallel. The way that we, did this with the series circuits is we said, okay, if we have one resistor instead of all 3, what would that be, in there? And so we're going to do a similar thing here where we say, okay, if we have one light bulb instead of all 3, what would that be? And so if we do 1 over Req, that'll be 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over 4 plus 1 over 8 plus 1 over 11. And we'll get our resistance of 2.146 ohms. Now, you've got to be very careful here because once you take these values, don't forget that it's 1 over Req. So you're going to have to cross multiply, then divide to be able to get your equivalent resistance. Once we've got that, we've got our, we've got our voltage, we've got our resistance, and the overall current in the circuit should be 2.795. So if you check that in the simulator, you should get that. Now, one of the other things that is really interesting here is the fact that in parallel, if we break this up into our final step, we're going to reconstruct. If we break this up into parallel, each gets full voltage. In parallel. And this is a huge idea because, in this case was at 6 volts, there's nothing else in here. This gets a full 6 volts, this gets a full 6 volts, and this gets a full 6 volts. And so what we can do is we can say, okay, I know that I've got 6 volts. We don't know how much current's passing through there. We have a 4 ohm, resistor. And so, and the top one, if we take 6 divided by 4, we'll get 1.5 amps. And that's actually how much current is going to be passing through this top one. And then we can do the same for these two. For the middle one, we'll have 7.5 amps, and the bottom one, 0.5454 repeating amps. And that's because, as it comes into here, you have 2.795 amps, but then it's split. The current is split up, and then afterwards, it all comes back together to be 2.795 again. And so in parallel, again, that the current splits up and is received on the other side as the same. All right, so for this one, this will be another practice. We've got a 24 volt cell, and we have 3 light bulbs in parallel here, 19, 22, and 4 ohm. So I'm going to have you work through this one. Go ahead and determine the overall current, what the ammeter will read, and then also how much current each bulb will use. And after you bring them together, and you can reconstruct and then draw the final picture there. The reason I have you draw these pictures here at the beginning, this transition step back to a new picture, a new step, is going to be kind of a checklist along the way. Right now we're just doing simple series in parallel, but pretty soon we're going to be doing combinations. So go ahead and work through this one, and when you're ready to check, you can hit play to continue. Okay, so the overall current, 8.35 amps, the equivalent resistance of 2.87 ohms. As we reconstruct, the top one will be 6 amps, middle one 1.26 amps, the bottom one 1.09 amps, and because all of them get the full 24 volts there.